So today's lesson we're going to cover what happens if I have an angle that's not on the unit circle. And this doesn't work for every single angle. This is also just a set of certain angles that work in this method. Alright, so the unit circle is useful. Well, it's very useful as long as we have specific degrees. If we have 30 degrees, 45 degrees, 60 degrees, 90 degrees, 0 degrees, 180 degrees, it's useful because we just got to find that measure of an angle. And it'll tell us what our sine, what our cosine is, what our tangent is, what our cotangent is, so on and so forth. But we have a whole bunch of angles that aren't on our unit circle. In fact, there's an infinite number of them that aren't on our unit circle. One, in example, is 75 degrees. So we will need our unit circle, so you might as well take it out now, because we will be using it. On the test, I will give you a unit circle, so you don't have to worry about that. But if you look at unit circle, 75 degrees is not on our unit circle. We can kind of point to where about it is. We don't know what value's there. That being said, 30 degrees is on my unit circle, and 45 degrees is also on my unit circle. And it just so happens that 30 plus 45 equals 75. Well, we're going to use this fact today to figure out what angle of 75 actually equals. The problem is we can't just add the two things together. We can't just find our sine at 30 degrees and our sine at 45, add those two numbers together and have our answer. Instead, we have these identities. We have these identities that need to be memorized because these problems aren't hard as long as you have these identities memorized. And in fact, tangent is probably the hardest one to memorize out of the two. Note on these, I have them written down for every single problem, but I just want you to note the top signs go with the top signs on their side. For example, if I have sine of A plus B, that's going to equal sine A cosine B plus cosine A sine B. Our cosine one is not a mistake. Alright, it kind of looks like a mistake, but it isn't. Cosine A plus B equals cosine A times cosine B minus sine A times sine B. So our cosine is kind of the alternate of what you think it should be. Alright, so we're going to use these identities to come up with angles that aren't specifically on our unit circle. So for example, I need to express tangent of pi over 12 exactly, and I can't use a calculator. Well, pi over 12 is not on our unit circle. Alright, so we need to figure out two angles that add together to give me pi over 12. Well, that's pretty easy when we have degrees. It's pretty easy to think of 30 and plus 45 gives me 75. It's a little harder when you have like pi over 3, pi over 4, pi over 6 to just in your head say, oh, when I add those together or subtract them, they equal pi over 12. So my advice to you, whenever you get to radians, whenever you have pi over 12, is rewrite the angles you know in terms of having a denominator of 12. For example, if I was doing this problem, I would immediately say, well, pi over 3 actually equals, if I want a denominator of 12, I'd multiply the top and bottom by 4. So that would give me 4 pi over 12. At least now we have a common denominator. I'm going to do the same thing for the other angles I know. So you might do pi over 4. Well, pi over 4 is going to be 3 times 3, or 3 times the numerator, 3 times the denominator, which is going to give me 3 pi over 12. In fact, we'd already have our answer right now, but I would just kind of go through pi over 6. Well, pi over 6, I'll multiply the top and bottom by 2. I'd have 2 pi over 12. And realistically, I'd only have to go to pi over 2 for these to work. Well, that would be 6 pi over 12. And realistically, these are the only ones we'd use. Now I just got to think about how am I going to use this to get to pi over 12? Well, our answer was actually right in front of us. It was the first two we did. It was because if I have 4 pi minus 3 pi, I'm going to get 1 pi out. We also could have did it here. We could have said 3 pi minus 2 pi. That gives me pi also. So I could have used these two angles or these. I'm just going to use the first ones because if I was on the test, I wouldn't go any further once I knew the answer. So we are going to rewrite tangent, let's write out the whole thing, tangent of pi over 12, well that just equals tangent of 4 pi over 12 minus 3 pi over 12, but it's going to be much easier to write in terms of the unit circle. So it would just be tangent of pi over 3 minus pi over 4. Pi over 3 minus pi over 4 actually equals pi over 12. I doubt you would have seen that unless you rewrote it. Alright, so you pretty much have to rewrite these in order to see whether you're adding or you're subtracting and what you'd get. Alright, so now I know tangent times pi over 3 minus pi over 4 equals that tangent of pi over 12. So then I'm just going to go up to our tangent of a difference, that guy. That guy right there is the one I'm going to use because I have pi over 3 minus pi over 4, and we're just going to fill in that information. So tangent of pi over 3 minus pi over 4 equals tangent of that first value, so tangent of pi over 3, minus tangent of that second value, which is pi over 4, all over 1 plus tangent of our first value, pi over 3, times tangent of our second value, which was pi over 4. Well, the cool thing is pi over 3 and pi over 4 are right on your unit circle. So if you're on a test, all you need to do is go to pi over 3 and write down what your tangent value is. And what is my tangent value at pi over 3? You should have a unit circle in front of you, so I should have more than one person raise their hand. What is the tangent value at pi over 3? Is there? Square root of 3. So you have square root of 3 on top. Minus, what's the tangent of pi over 4? Anyone just shout it out? 1. Well, that means I have the whole bottom too, because it's just 1 plus tangent of square root of 3, but we already said that's square root of 3, times tangent of pi over 4, which is going to be 1. I'm going to rewrite this just a little bit. I'm going to rewrite it as square root of 3 minus 1 over square root of 3 plus 1. I'm okay with that answer. But I'm going to show you how to simplify it if need be. Say you're on like an SAT and this isn't one of the answers that they give you. So I'm okay with this, but to simplify it, I need to multiply it by the conjugate of our denominator. And we'll see how that works. So I'm going to multiply the top and bottom by square root of 3 minus 1 times square root of 3 minus 1. So that's the conjugate of my denominator. Well, our top is square root of 3 times square root of 3, which gives me 3. Maybe I'll put some parentheses around both of these, just so we can see what happens. So we have square root of 3. I got square root of 3 times negative 1, but I also have square root of 3 times negative 1, so that's minus 2 square root of 3s. And I have negative 1 times negative 1 gives me a positive 1. And it's going to be all over. The whole point of doing a conjugate pair is that they're difference of squares, which means if I have square root of 3 plus 1 times square root of 3 minus 1, it's just our first term squared minus our second term squared. So that's going to be square root of 3 squared minus 1 squared, which is going to equal, simplifying a little bit further, we're going to have 3 plus 1 is 4 minus 2 square root of 3 all over, well this is just 3 minus 1, which is 2. That's going to simplify further to 4 over 2 minus 2 square root of 3 over 2, which is just going to equal 2 minus square root of 3. Make sure at least you have this written down. Alright, like I said, on a state test or something like that, they're probably going to want it in the most simplified form, so you have to know how to do that. But I'm more concerned about your procedure on the test then that you can simplify a square root in the denominator, because that should have been covered in Algebra 1. Geometry we do it in Algebra 2. So you should be versed in doing it, more concerned about that first answer. Questions on any of those steps? Okay. Now we're going to do the cosine of, the cosine of a sum. Once again, this one's in radians. So what I'd always do is I would go pi over 3. Well, that's going to equal, I want the denominators to be the same. So that's going to be 4 pi over 12. Then let's do pi over 6. Now let's do pi over 4, I rewrite that, that's 3 pi over 12, and I can stop right there. Because 4 pi plus 3 pi, pretty sure equals 7 pi. Alright, so that cosine of 7 pi over 12, cosine of 7 pi over 12 is just going to equal cosine of 4 pi over 12 plus 3 pi over 12, which is the exact same thing as cosine of pi over 3 plus pi over 4. Alright, so we're adding, so that must mean we're doing that cosine of sums right there, which unfortunately has a negative sign in it. Alright, this is going to throw you off, so make sure you study and memorize that this one actually has a negative sign in it. For cosine of sum, we have cosines on one side of our addition or minus sign, and we have the signs on the opposite side. So when I rewrite this, it's going to equal the cosine of that first number, which is pi over 3, times the cosine of that second number. Maybe I should put those in parentheses, of that second number, which is pi over 4. Subtraction, and sine of pi over 3 times the sine of pi over 4. So this one's a little tricky to memorize just because it's the wrong sign, realistically. Because we're thinking, I'm using a sum, I should have sum in here, but it actually has difference on the other side. Now I just take out my unit circle, and I'll have my answer. So we look at our unit circle, and what's our cosine value at pi over 3? And that's our first, yep, 1/2. So that's 1/2. What's our cosine at pi over 4? So that's times square root of 2 over 2. Well, the nice thing is if you know your sines and cosines as well as you should immediately not have to look at unit circle anymore. Because what does 1/2 always pair with? Whenever one is 1/2, what does the other one have to be? Yeah. Square root of 3 over 2. And anytime one of them is square root of 2 over 2, the other one must also be square root of 2 over 2. Well, whittling our way down, we got 1 times square root of 2, which is square root of 2, over 2 times 2, which is 4. Minus square root of 3 times square root of 2, if you remember, is really square root of 3 times 2, so that's square root of 6, over 2 times 2, which is 4. They have a common denominator already, so it's just going to be square root of 2 minus square root of 6, all over 4. Alright, so since I'm giving you the unit circle on the test, the hardest thing you need to do is straight up memorization. Memorizing these. You don't have to memorize one, you just got to remember where the negative signs go and positives for the other one. Alright, the last one we're going to do is if I have sine of 15. Well, can someone come up? I'm not going to give you this one. Can someone find 2 degree measures when added or subtracted giving me 15 and just both happen to be on our unit circle? Yeah?
45 minus 30.
45 minus 30, perfect. We could do 45 degrees minus 30 degrees. The degrees are nice because I don't have to convert anything. It's just 45 and 30. So this is just going to equal, well, since I'm subtracting, we're going to use the difference, which is going to be sine of my first number. So sine of that 45 degrees times the cosine of the other number, which is 30 degrees, minus cosine of the first number, which is 45 degrees, and sine of the second number, which is 30 degrees. Now all we need is our unit circle. What's the sine of 45 degrees? It's our second tick, right?
Square root of 2 over 2.
Square root of 2 over 2. All right, just shout it out. What's the cosine of 30? 1/2. All right, that must mean the cosine of 45 degrees is square root of 2 over 2. And the sine of 30 degrees must be square root of 3 over 2.
Would the cosine of 30 degrees?
Oh, hang on. It would be flipped. It'd be completely flipped, right? Cosine of 30 degrees should be square root of 3 over 2. The sine of 30 degrees is 1/2 because it's our first tick. All right, so square root of 2 times square root of 3 is going to be square root of 6 over 4. Minus square root of 2 times 1 is square root of 2 over 4. Well, this is just going to equal square root of 6 minus square root of 2 over 4. So once again, I will provide the unit circle. You only have to make sure you know these sum and difference identities. I'm not overly concerned about this last part. I just want to make sure you're aware of them. The reason why I'm not too concerned about it, I have to give you very specific problems for these last ones to work. So if you look at your unit circle, you'll notice that our sine and cosine numbers constantly repeat, right? They have a pattern. We only can use so many numbers. So that boils down to the fact that we have these cofunction identities. A trig function of an angle is equivalent to the cofunction of the complement of its angle. In other words, if I have cosine of a number, it's going to be the same thing as sine of pi over 2 minus that same number. And that's based upon the fact that our numbers just keep repeating. So for example, if I need to use the cofunction identity to find the exact value of sine of 5 pi over 12, so if I'm doing sine of 5 pi over 12, all I'm going to do is, well, I'm going to write down that the sine of u equals the cosine of pi over 2 minus u. Well, I already know what u is. U is just that 5 pi over 12, which means that's going to equal cosine of pi over 2 minus 5 pi over 12. Well, creating a common denominator, I need 12 on the bottom of the other one, so that's multiplying the top and bottom by 6. So we'll have cosine of 6 pi over 12 minus 5 pi over 12, which actually equals pi. Let's put the whole thing in there. Cosine of pi over 12. Now, in the book and in your homework, these are going to come out to ones that you can find on your unit circle. Can you find pi over 12 on the unit circle? Like, is it just one of our notches, though? Pi over 12 isn't. No. Okay. Yeah, pi over 12 is not on our unit circle. So if I wanted to find out this exact answer, I'd have to go all the way back to the fact that pi over 3, right, where is it written? Pi over 3 minus pi over 4 equals pi over 12, and solve it. I'm not going to make you do that on this one. But in the book, they're going to come out to ones that are already on the unit circle. So I'm just going to give you the answer right now. Note that this isn't all of the work that would be required. So there's work in here. So there's work we're missing. And it would end up equaling, I put it down, square root of 2 minus square root of 6 over 4 if you did all that work. The only point of doing this is if I give you a very perfect question, you can possibly plug it in here and it'll come out to a value that's on the unit circle. All right, so it has to be like the perfect question for this to actually work. That's why I don't feel this is as crucial, because it's not used so much in the real world, because it's predicated upon the question being perfectly asked. Okay, so it is in your homework, but don't expect this to appear on the test. Okay, but it is in your homework. I want you to see it, just in case you see that term, cofunction identity. That's what they're referring to. Basically, they're saying, hey, guess what? These numbers repeat on the unit circle. If I just take that angle you have and shift it a little bit, it's going to be the same as the sine as some other quadrant, or other quadrant. Okay? Any questions about what we did today? All right, go ahead and start the homework.